Hello everyone, welcome to AI Anytime channel. So in this video, we are going to build a question answer application using large language model. Okay. So we'll use OpenAI to build a QA app using Gradio. Okay. So it's going to be a very simple but at the same time very powerful application. Okay. So you can have your multiple documents, right? So you have your PDF, you have your doc, any kind of text data that you have, that can be web pages as well. Now you have abundance of documents and you want to build a QA pipeline or QA application that will take all those documents or the text data and kind of create a large chunk of corpus where you can interact with the application, and you can ask your queries, and the application should retrieve the information from those corpus, and it should give you the relevant information. So we're going to use OpenAI, of course, to build this application, but at the same time we will also have a look at couple of very powerful and very instrumental libraries, okay, that has been launched in the last few months. Okay, we will have a look at something called LangChain, and we'll also look at GPT-Index, which is also called as Llama Index. So we're going to see this library. If you see, currently I'm on LangChain GitHub repository, which says, if you see the description about building applications with LLMs, which are large language models, through composability. Okay. Now we are going to have a look what really composability means and why it is so important, okay, when you are working with large chunk of text data or large corpus and you are interacting with this LLMs. Okay, how you can utilize this composability, which is a system design principle. I will talk about it, and we're also going to have a look at something called Llama Index. Okay, so we are going to use GPT Index from Llama Index, and it will help you connect your external data with OpenAI. Okay, in very layman terms. Okay, so first we'll talk about LangChain, and then we'll go ahead and build this application with Gradio, which provides you a very this provides you a framework where you can use this library to build a simple UI. So we have a lot of frameworks coming in lately. We still have Streamlit, we have Flask, we have Django, and we have Gradio, which is very simple. So in end, the output of this video will be an application. Okay, so in end you will have an application running on Gradio. You can share that with your friends, and you can interact with the application for your question answering. Okay, so we'll use a document. We'll use GPT-4 technical report that was published by OpenAI last I think this month only. So we're going to use that document. We'll create our embeddings on top of that document with the help of LangChain and of course OpenAI indirectly, and then we are going to ask our queries related to that document. Okay, now why LangChain is important here, guys? Okay, if you see, it says building applications with LLMs through composability, and it says large language models are emerging as a transformative technology, but using LLMs in isolation is often not enough to create a powerful application. Now let's understand first what composability is. So composability is a system design principle that deals with the interrelationship of components. Now you can have multiple components while you are building an application. So you can have, suppose for example, if you have an application where there is a component called email sending. Okay, you have a set of code that kind of works when you have to send an email, and then you have something called PDF download, and then you have something called root cause analysis. So there are different components sitting in silos, in isolation in your applications. So composability, which is a design principle which is very powerful, helps you connect this. Okay, this is basically for interrelationship of components. Okay, so a highly composable system provides components that can be selected and assembled in various combinations to satisfy specific user requirements. Now this is the definition of composability. You can also read it on internet. You can Google composability and you can find it out what that really means. But why it's important for large language models? Now imagine you want your LLM to answer questions over a large corpus. Now you can have a large corpus, and your LLMs to answer questions on those corpus. So it's very difficult, right? You cannot pass the entire corpus in the prompt. You cannot pass your entire large corpus that you have, the text corpus, to the prompt. It's not possible right now. So what are some of the steps that you can follow, right? So if I take this, one second. So I'm just connecting my, okay. So now, what are few of the steps that you can do to pass this entire corpus in prompt? So we talk about prompt engineering. So I will tell you what is prompt plumbing. Okay, now why prompt plumbing is better than prompt engineering. So few of the steps that you can do, you can first pre-process. Okay, you can pre-process the corpus. You can pre-process the corpus into the by iterating over So you can pre-process your text corpus that you have by iterating over the documents. Suppose you have a document, so you have to first pre-process it. The next step is to splitting them. So split them into chunks, into smaller chunks, splitting them into chunks. And then you summarize them. Once you summarize them, now what you can do, you can embed those chunks. Or you can also call it summaries. That summarization that we have done in the above step. And where are we going to embed those chunks or sentences? We are going to embed those in some kind of vector space. Okay, so if you are familiar with natural language processing, you might be aware about these vectors. So in some vector space. Now this is the step these are the steps that you have to follow. Okay, when you are dealing with large text corpus. Okay, and you want to work with the large language models with those text corpus. Now when you get a question, so suppose I have a new queue. Okay, this is the question. What it does, it kind of search for the vector space. Search for your vector space, the vector space that you have created over in this step, D step, right? It search for your vector space, for similar chunks, the question that you have asked, right? For similar chunks, this question that you see, this question that we have here, okay, that you have asked, okay, and of search for the vector space that we have in the point number D, and once you get for the similar chunk, okay, in the prompt along with your question. Okay, so you have it send it to the prompt along with your original question that you have asked. Okay, now this process is called as prompt plumbing. This process that you have seen, okay, and it's better than prompt engineering. Okay, we are talking about prompt engineering nowadays because you see, I think not days, I think hours of the day you might be seeing some kind of models like generative AI models are coming up. Organizations are working with different models. Okay, so when you're working with large text corpus and you want to use a language model, okay, to process those and try to come up with an actionable insights, these are the standard steps, okay, the procedure, okay, when you're asking question. So when you get a question, you have searched for your vector space for similar chunk and then pass those chunks, okay, to the LLMs, whatever LLM you are using in the prompt along with your question, and you get your answer. Okay, so this is the plumbing that we are doing. Okay, this is for LangChain. Okay, I will also explain when I'm going to write the code now. We'll also explain what it really does, from the code perspective. Now we're also going to use something called, in this we are going to use something called GPT. We are also going to use something called GPT-Index, which is basically also called as Llama index. you can have a look here and this GitHub repository. Basically it helps you with the data ingestion and data indexing. Now what it does, it takes a data structure approach. Okay, yeah, this is a very fascinating, okay, when you go and read more about GPT-Index. So this is beyond the scope of this video. Okay, we're not going to talk in detail that what kind of approach it follows to work with your data. Okay, so it takes a data structure approach, GPT-Index, and it allows the LLM. So suppose you have OpenAI, we are using DaVinci 3, for example. We are going to use DaVinci 3 in this tutorial. So we have DaVinci 3. So what it does, it allows the DaVinci 3 model to connect with the external data. So we have our external data, that GPT-4 technical report, the PDF document that we have. So it helps you connect to the external data. It is also called knowledge base. That can be one document, can be multiple documents. So it allows LLMs to connect with external data, and this is what we are going to use. So we are going to use GPT-Index and LangChain, to create a question answering application in Gradio. So what I'm going to do now, I'm going to my VS Code. You can see this is my VS Code, and I have some already listed requirements.txt. Okay, so you have to create a requirement.txt if you want to create a virtual environment. If you are using Anaconda, if you want to install it directly, you can also install it. So I already have a virtual environment over here, you can see, and these are the dependencies that we have to install. So OpenAI, because we have to interact with DaVinci 3 model, and then we have GPT-Index. As I said, it allows DaVinci 3 to connect with the external data, and that data is nothing but the GPT-4 technical report. And then we have PyPDF2, a very famous Python library for PDF operations. So you can do any kind of operations with PyPDF2: editing, manipulation, downloads, processing, getting informations, or anything. Then we have Gradio, which is kind of a web framework, okay, or library which helps you, a Python library basically, which helps you create minimalistic UI. Okay, and then we have .env. This is basically to handle this env file. So what we have to do, we have to create an app.py. So I've created an app.py. If you haven't still created this venv, how you can create? You can create using Python -m venv.venv, which is your folder name. But already I have done it, so I'm not going to do that. You can create that and then you can activate it. Okay, so you have to activate. If you are in Windows, you have to go inside the scripts folder, and then you have to activate this virtual environment. If you are on a Linux machine, you have to go inside the bin folder, and then you have to activate it from there. So this is my app.py. Okay, now let's do one thing. Okay, as I told you that which document that we are going to use. So we are going to use this document, which is GPT-4 technical report. Okay, so I'm going to use this document. Okay, GPT-4 technical report, which is around 99 pages. Now just understand, guys. So suppose here I only have 99 pages, but you have multiple documents containing thousands of pages. Each document contains more than 1,000 pages. How difficult that is for a human being to go through those documents and then try to retrieve some kind of information. So this fits in the entire ecosystem of your organization where documents are involved. Now that can be insurance document, policy documents, contracts, banking document. That can be your API manual, software documentation. That can be any kind of document that you have. You just give it to GPT-3 or 4 also, and you create a question answering bot or a question answering application, and you can also integrate in your existing application if you have at your current organization. So this is what we are going to do. So we'll use this GPT-4 technical report, and we are going to ask some of the queries that we may find relevant. Okay, that is that is somewhere in this document. Okay, so let's start. So I'll go back to my VS Code. I already have my API from OpenAI. If you don't have an API, you have to go to OpenAI dashboard and you have to take an API. So what we are first going to do, I already have installed. So first I have to load. Let's first import the utilities. Okay, so first is import OS. Okay, and then I'll import sys, basically system, and then I will also import from .env, import load underscore .env to handle the API keys of OpenAI. And now let's also import Gradio as gr, and import Gradio as gr, and then we're also going to import a couple of things from LangChain and then a few of the things from GPT-Index. So from LangChain import, and how you're going to install LangChain, it's all in the requirements.txt. So you just have to install GPT-Index and OpenAI, that's it. So from LangChain import OpenAI. Okay, from LangChain import OpenAI, and now we have to import a couple of things from GPT-Index. So from GPT-Index, okay, you can see it's already suggesting me. I'm going to import first is the simple directory reader, because what this module does, simple directory reader, it helps this set of code or the function to load the data. So we have a PDF file, so it will help you load the data from directory. So simple directory reader is one of the things. Then we also need some of the list index, so we have to index those, right? So GPT list index being one, and then we also need vector index. So that's called GPT simple vector index. Okay, then we have GPT simple vector index. Then we need some LLM predictor, which is our core here, and then we need prompt helper. Okay, so these are the imports that we have, for now. Okay, so now we have imported. So now let's get this method here, load.env, and now we'll use os.environment, and then we'll use openai.api key, and I'll just load it from my get.env or that env file. So that let's call it os.get.env, and this will be OpenAI API key. I think I have just made open. So this will be OpenAI, not OpenAI, open. So this will also be OpenAI, and we have done this. Now we will write two functions. The one function will be for the constructing the index, and the second function will be the chat bot or the QA bot or whatever you call it. That function will be there. So let's write the first function. So the first function that we are going to write, we are going to call it def construct index. So def construct underscore index. This is going to be our first function, and in this we only have our directory path. So let's call it directory underscore path. That makes sense. Construct index. Now first thing is we have to first define some of the parameters here, some of the value that that helps you for getting the response. So maximum input size. What's going to be your maximum input size when you are writing the text, okay, in your prompt? Okay, so I'm just going to call it, let's keep it standard, which is 4096, and then I'm going to say number of this is for your output basically. So number of output is going to be, let's call it 512, because we are still using GPT-3, okay, DaVinci 3, which is also being flagged as GPT 3.5, okay, which is based on Instruct GPT. So we are using GPT-3 here. If you want to use GPT-4, if you have got the access from the waitlist, please go ahead and use GPT-4, because it is cheaper than GPT-3 on a per tokens. So you can also use GPT-4 if you have the access. I haven't got the access yet, that's why I'm still using DaVinci 3. So max input size 4096, number output 512, and then I also have maximum chunk overlap. Okay, so maximum chunk overlap, which is 20. So as I shown in this when we are showing on the tab, okay, that how you have to follow the procedure when you are working with large text of large chunk of data. You have large corpus, so you need to chunk those, right? So you're also using max chunk overlap here 20, and then chunk size limit. So I'm just going to call it chunk size and chunk underscore size limit, and I will keep this at 600. Okay, this is going to be the limit, maximum limit of chunk. Okay, so chunk size limit, this is done. Now we have imported few of the modules, being LLM predictor and prompt helper are among those. So we are going to use prompt helper. So prompt underscore helper, this variable, let's create this variable, and then we're going to use this module from GPT-Index. prompt helper, and we'll just use the above defined parameters. So maximum input size, so let's use maximum input size, and then we'll follow, let me just follow the same order. So maximum input size, then we have num outputs, so we'll use num outputs. And you can also use, so you can have a look at here, right? It says max input size and max chunk overlap, number output. So you can also say max underscore input size equal to your variable name. You can also do that. So I'll say max num underscore output, then max chunk overlap that we have defined, and then we have chunk size limit. So what I'm trying to say is that you can also do like this. Okay, so you see this here, in the documentation of this function, with a chunk size limit. So you can also do something like this, chunk size underscore limit equal to this chunk size limit. So you can also define like this, chunk size limit. So what I'm going to do now, I'm just going to do this. Let's do Alt G so we can have a look. So prompt helper is done. We have maximum input size, num outputs, max chunk overlap, and chunk size limit equal to chunk size limit. These are basically the arcs. You can also follow the arcs procedure here. It looks good. It's a good way of writing code. Okay, so prompt helper. Now we are going to use LLM predictor module. So LLM underscore predictor, which is a variable LLM predictor, and here we are going to interact with OpenAI. So I'm going to call it LLM. So in your LLM, you have to write that we have imported here from LangChain, import OpenAI. So in OpenAI, here we'll have our OpenAI set of parameters like temperature to control the randomness and creativity of your response. So if you have worked with any of the OpenAI or GPT-3 model, you will know what I'm talking about. Temperature and then penalties and so on, right? So here we have LLM equals OpenAI. The first thing is temperature, so let's call it temperature, and my temperature equal to be 0.7, which is very standard. So temperature equal to 0.7. Then model name. So what model I'm going to use? So my model name is going to be DaVinci 3, as I said earlier. So text DaVinci 003. This is going to be my model, and then I'm going to use max tokens. So max tokens, max underscore tokens, and this max tokens are nothing but the number outputs. So this is what I'm going to use here, number outputs. So our prompt helper and LLM predictor are done. Okay, so in LLM predictor, what we are doing here, we are connecting with the DaVinci 3 model. You see OpenAI, and we are using temperature as very standard value 0.7, and then maximum token as a number of output. Now what next? Prompt helper, LLM predictor, and the next is to load the documents. So I'm going to call it documents, and we'll use this simple directory reader. So what we have to do, guys, before that, okay, we have to go inside this projects QA app, and we have to create a folder called docs where we'll keep our documents. So I'm calling it docs, and in this docs we have to use this GPT-4 report. So now let me go back to VS Code, and we'll see this docs folder. So whatever documents do you have, okay, so if you have documents, for example 50 documents from different industry or for any other knowledge base that you have to keep in this docs folder. So place your PDFs inside this docs folder or any other format of data, but you have to process that before passing it to GPT-Index. So inside this docs folder, I have only one file, one document for this video, which is GPT-4.pdf. So in this simple directory reader, what I'm going to do now, I'm just going to do directory path, which has been also been our parameter here in the function, right? And then I'm going to just say load underscore data. So it will load the data, okay, from this directory path that we will use in the other function. So documents, simple directory reader, this is done. Now we have to index it. So index equals GPT simple vector index, and inside this GPT simple vector index, I'm going to pass documents, the document that we have loaded the data from this directory. This document is going to be passed here for this GPT simple. And now in LLM predictor, I'm going to pass LLM underscore predictor, and then in prompt helper, I'm going to pass prompt helper. prompt helper. So index is done. So now what next? So this will so we have to save the index. Now it's very important to also save this index. So you will get an index. I think most probably it is a JSON file. So we will get index.json, and we should save that in our local directory. So what I'm going to do now, index.save to disk function. Sorry, not dict. It's save to disk. I'm going to use save to disk, and in this path I'll just save it my same directory. So I'm just going to call it index.json to save it in the root directory I am in currently, and I'll just return this. I'll just return the index. That's it. So this is the first function, okay, where we are dealing with LangChain, and we're also looking at this data GPT-4 technical report, and we are using prompt helper, LLM predictor, and then we are using GPT simple vector index to index it, and then save that to our root directory as an index.json file. So what next now I'm going to do, I'm going to write one more function, and let's call it QA bot. I'm calling it QA bot, def QA bot, and I'll just say input underscore text. So in QA bot, input underscore text, and here what we have to do, let's first have index, again index GPT simple vector index dot load. We'll load this index.json. So again it will be load from disk, and then let's load this file, index.json file that we have saved it. Okay, so you'll not be able to see right now because we haven't run the code yet. Okay, so index.json, and now we'll write our response. So response equal index.query, whatever query that we will ask, okay, whatever query that we'll have. Okay, so for input text, this is going to input text response. This is a response mode, so I'm just going to say response mode. There are different response mode. You can have a look at response mode in dir in GPT-Index, that when you are importing it, you'll be able to see that different type of response mode. So I'm going to compact, response mode equal to compact, and now just return the response dot response. Okay, so it's response dot response. So this is the QA bot. Okay, so what we are doing here, we are loading this index.json, and then we are doing our response prompt, and whatever query we'll have, it will give you a response in a very compact. Okay, so it will not give you too big, okay, of answer or relevant information that you have. It will give you a very compact answer. Okay, so return response dot response. Now we'll create the interface for the Gradio application. So let's call it iFace or interface, and I'm going to call it gr.interface. gr.interface, and we'll write our code here. So gr.interface, excuse me, sorry, and we are going to call it, let's call it, so what function that we are using. Okay, so I'll call it for example, let's call this QA bot. Okay, and then you can see function which is callable function. If you read this functions documentation here, it says class interface, this class that we are using from Gradio, it says the function callable. Okay, so you have use the callable function here that you are going to call. So fnq QA bot, okay, QA bot, and then we are going to write inputs. So what I'm going to do, my inputs, my input will be gr dot, you can see it's suggesting me inputs. Okay, excuse me, I'll just have a text box here. So gr dot inputs dot text box, and in this text box how many lines of text box you want. So I'll say for now let's keep lines as 7, and then we'll have label. So let's have this label, and we can call it enter your query. This is going to be my input box. So I have a function QA bot, and then we have the input. Now what next we have to do is we have to do the output. What outputs that we'll get? So output will be nothing but the text. Okay, so output will be nothing but the text. So I'm going to call it text, and in last let's have a title for this app. Okay, so title will be custom trained So let's have a hyphen custom trained QA bot or QA application. This is going to be the iFace, okay, interface variable. And now we have to let's index, and we are going to use that function. So construct index, and our directory is nothing but the docs. So docs, where we have the file, and then we are going to launch the interface. So how do we launch a Gradio application, which is iFace.launch, and you can see it's showing you everything. Okay, so it also has a feature called share. So you can share these applications with your friends. You might have worked with Engine Rock or NG Rock, whatever you call it, and it also helps you, to when you are running an application inside a tunnel. Okay, you have some port tunneling, and when you have an URL link, you share that URL link with your friends. If your app is running in your system, your friends or your peer or your teammates can also access it, on internet. So this is how you can also use it here. So I'm going to use share equals to true because I want to share this, right? So I need a live link. Okay, so this is the application that we have built. This is the code that we have written right now or so far. So what we're going to do now, let's run this. So let's first have a review what we have done. We have imported all the required dependencies. Then we have created a function called construct_index that takes this file gpt4.pdf, and then first connect with the OpenAI, okay, DaVinci 3 model. We'll getting this index, we are saving this index.json in our local directory, and then we are using one more function called QA bot that we are loading the index.json, and whatever queries that you ask, it will try to look for the similar chunk, okay, in those index.json, and then it will give you a response. Okay, this is what it does, and we are returning response.response, and then we are creating in iFace, which is Gradio.interface, and we have this callable function which is QA bot, and our input is a text box where we will input our queries, enter your query, and then we have outputs as text, and then we have title as your app title, and then we are passing that file to this function, and then we are using the Gradio application to interact with. So let's run it and see if we are able to get the desired response, or we are getting any kind of error here. So let's do that. So python app.py. So it might take a little time because it totally depends on the number of pages that you have, how big your data is, and also on your internet bandwidth, because it has to connect with the OpenAI server, and you send the data to them, and then kind of get the model trained on your custom data, and then you get the response. So you can see we have total embedding token uses, so around 80,000 of tokens. Okay, and you can see we're getting a Gradio live application. Let's copy this application. I'll just copy, and I'll come back on my browser, and I'm running this application. So what it will do, it will launch a Gradio application. You can see it says custom trained QA application. So this is the QA application, question and answering. It's not quality assessment. We haven't built it for testing tool. This is the question and answering application. Now you can see I have an input area where I can input my text, which is query, and then I have an output where I will get the output. Now we also have some of the features called flag. I'll tell you what flag means. Okay, so flag means like when you want to keep a log, okay, of your entire activities on Gradio application, it will save that in a CSV format, okay, inside a flag folder. I'll show you what I'm talking about. Now let's open that file, GPT-4 that file that we have, GPT-4 technical report. So this is the file that we are going to use, guys. Okay, so it released on 16th March 2023. So it was published by OpenAI. Okay, so we'll ask some of the queries. Let's read it. So I have already read it. Okay, it's a very interesting paper to read. So let me ask some of the questions. Let me first have a look. So it has around 100 pages. Okay, so let's ask about the limitations. Okay, so my first question will be, can you list some of the limitations of GPT-4? This is my query. So I am passing this query now, okay, in this Gradio application. What it will do, it will have a look for the similar chunk, okay, in that vector space, when we created that LLM, when we were using that index, using LLM predictor, we have saved that index.json file, right? So it will go through that, it will look for the similar chunk in those vector space and then try to come up with the relevant information for this particular query. So let's hit the submit button and see if we are able to get any response. See, here we go. So we have got this information in output, not fully reliable. This is the first limitation. Can suffer from hallucinations, has a limited context window, does not learn from experience, potential for bias, because as always LLMs are still biased, because the bias is not in modeling, the bias is still in data, the data that they have been trained on. So they are still biased, then the potential for bias. You can of course eliminate the bias. Then sometimes it also gives you disinformation, some inappropriate information that might not be correct. Then it kind of some of the limitations are privacy and cyber security and proliferation risk. So this working, I will say good. This is good. Okay, this is a very good start, I will say, because it took us 30 minutes only to build this application. So you have a set of documents, you just pass this document, you use LangChain and GPT-Index, and you come up with this kind of application. Okay, so you can also use this at your workplace, and you can, because at workplace in organizations we have multiple knowledge bases. Okay, and all those data are sitting in silos. You can bring all those documents together, can create a single platform and use this technique to have this QA pipeline or QA application. So now let's go back to this folder, guys. Okay, so I'll go back to folder, and you can see now I have a folder called flagged. Okay, so in flagged I have nothing right now, but what if I just click on flag? Okay, when I hit this flag, it saves the response. Okay, so let me go back to VS Code so you'll be able to see, and let me go inside this flag. I have a file called log.csv. When you click on log.csv, it kinds of keep the track of your entire activity on that Gradio application. Okay, so this is fantastic, right? So now we have also an index.json. If you click on, and it's huge, right? It's 80,000 of tokens that you saw in the terminal. You can read it entirely here. It's a huge chunk of text data here, the data, that is the information from that GPT-4 technical report. Let's ask some other question also and see if you're able to get any response. Can you list some of the capability? Let's change it to capability. So I've asked this, can you list some of the capabilities of GPT-4? Why should I use it? Now this is my query, okay, to this, and you can see a fantastic response, a very compact response. Now you can also play around this, the compactness, and you can control this response, okay, using GPT-Index, that's the function that we used when you are loading it. So it says some of the capabilities of GPT-4 include outperforming existing LLM models, and then what it's saying, 26 languages, and you should use GPT because it is powerful tool for NLP tasks such as text generation, and then can be summarizations and question answering. That this is what we are doing. See, this is the response that we also got from GPT-3 basically, or GPT-4. Okay, that the document that we are using. It is also capable of learning from, making it a useful tool in machine translations and dialogue systems, which are very instrumental when you want to achieve AGI in future. Machine translation and dialogue systems are something that will open the door for AGI. So additionally, GPT has been designed with safety in mind. Okay, because you might have seen the CEO of OpenAI, Sam Altman. He was talking about they are very focused towards the responsible AI when they are creating this kind of large language models. So this works perfect for me. This is working fine. You can have multiple documents, bring it in the folder, and then get the index with the help of GPT-3, and also use a LangChain and GPT-Index to work with it. So this is what for this videos, guys. I hope you liked it. The code will be available, and just for just to see here, it also sees for whatever question that you have asked, it says total LLM token uses. For the first question that we ask, the limitations, it uses 625 tokens, LLM token, and embedding token were 13 embedding tokens, like the embeddings that we have shown, right? So, and for this, the second question, 741 token, which makes sense, because the response, if you see, it is I think 2 paragraphs here. That's why you can see the embedding token uses and 19 tokens. So this is working perfectly fine, guys. So what I will do, this code will be available on this GitHub repository, AI Anytime of GitHub repository. You can also find that in the description of this video. So if you like this video, please share this video with your friends and peer. If you haven't subscribed the channel yet, please do subscribe the channel and share this channel link with your friends and to your peer. Okay, I hope you liked the video. That's all for today's videos, guys. See you in the next video.